Hello learners, welcome to Black Slides on online education. This is a facility that is offering you tuition while you are at home through the internet. So you're most welcome. We are the online education providers offering quality tuition to students or learners while at the comfort of their homes. You can get us on the contacts shown here. This cell phone number, which you can also text to on WhatsApp, or you can send us any inquiries to the email shown here called blackslidestutors@gmail.com. We'll be glad to come back to you on your request or any inquiry you make. So we offer tuition to students that are to take any of these exams: JCE exams, which are taken in Form 2 of Malawi curriculum; Msce exams, which are taken in Form 4 in the Malawi curriculum again; or if you are taking a Cambridge exam, which is called IGCSE in Form 5 of the national curriculum, you are also welcome. So the subjects on offer are physics, chemistry, mathematics, and biology. So you are most welcome. Please inform your friends who are struggling to find quality tuition online. We are going to welcome them and offer them a very affordable online tuition. At home. So feel free to interact with the lesson and to interact with the teacher to make sure that you are taken on board in understanding what is taught to you online. All right, so this is our second topic. In topic number 1, which we had online, we were looking at the use of the cosine and sine rule to solve triangles given enough information. In topic number 2, I'm going to take you through a topic called vectors. And since we cannot talk about vectors without mentioning scalars, so the topic is vectors and scalars. It is suitable for Form 4 candidates who are to sit an exam in mathematics, It is suitable for those who are taking ADMA. You get some knowledge that's useful in a topic called kinematics or vectors proper. All right, it is suitable to those sitting an A-level exam. It is suitable as an introduction if you are taking an A2 exam of that's an advanced subsidiary, AS exams rather, advanced subsidiary of the United Kingdom. All are welcome on board. Great. So let us look at basic definitions that are useful in the topic. Remember that to unlock the understanding of any topic, you need to define that topic. So we are going to define the concept called vector. What is a vector? We define a vector as simply a quantity. You know, remember that a quantity is anything that can be measured. It's measurable. So vectors are measurable. So it's a quantity which is specified fully by its magnitude, for example, length, and the direction. Alright, so a vector is a quantity with both magnitude and the direction. Magnitude simply refers to size, how big something is. For example, length. Alright, how big in terms of maybe numbers, 10, 15, 20, 5, 100, and so on, magnitude, how big something is. And the direction attached to it. So the direction can be in form of an angle, in form of a cardinal points, in form of left or right or up and down. So such a quantity which has both magnitude or size and the direction is called a vector quantity. It's a vector quantity. So it's a quantity. It's a measurable property. A quantity is a measurable property which has both magnitude and the direction. You meet this definition also in physics. If you take physics, we have a topic of vectors and scalar quantities. All right. So examples abound. We have examples such as gravity. Remember, gravity is the Earth's pull on an object which is in its field. For example, falling bodies. All right. This is simply the Earth's pull, the pull of the Earth on an object which is in its field. For example, when you drop a body from a certain height to the ground, it is being pulled by a force called gravity, which is also called weight of that object. All right. Another example is velocity. velocity. All these are examples of gravity. Velocity is another one. So velocity, you remember, in kinematics or linear motion, right? In physics, okay, or in additional mathematics, velocity is simply the rate of change of displacement of a body with time. So it's a vector. Remember, displacement is distance in a specific direction. So velocity is also an example, apart from gravity there. Another example is force. Remember, force is what? Right? A pull or a push on an object, which causes a body being pushed or pulled to change its position or to accelerate. All right? Force. Gravity, velocity, force are examples of a vector quantity. All right? You can think of other examples based on your experience and learning, previous learning, of vectors and the scalar, of vectors. So we have gravity, velocity, force, and others. On the other hand, the opposite of a vector is a scalar, or some say scalar. Scalar, I prefer to say scalar. All right. So a scalar is a quantity also, but it is fully described by magnitude alone or size alone. There is no need to attach direction to it. So it's fully described in terms of magnitude or size, how big it is. All right? Magnitude is enough to describe a scalar quantity. There's no need to say to add or to attach direction to it. Examples include time. For example, the time now is 5 minutes past 4 a.m. All right? The time right now, at the time when this is the time I'm preparing this lesson for you. All right? It's 5 minutes past 4 a.m. There is no need to attach direction to that time, to say the time is 5 minutes past 4 west, or 5 minutes past 4 north, or 5 minutes past 4 left or right. You know, the left, right, north, west, those are not important to describe time. All right? Another one is speed. Speed is what you learned in the linear motion as the rate of change of distance with time. All right, so it's just distance divided by time. All right, no need to mind direction there. All right, but also mass of a body. Remember, mass is a quantity of matter, all right, contained in a substance. How much matter is contained in a substance is called mass. All right. So time, speed, mass, these are examples of scalar quantities. They are not vector quantities. They are fully described by their size, how big they are, You know, that's all they need to be described. It's this magnitude. No need to say to attach direction, aspect of direction to it. A vector quantity is named using letters at the end of the directed line segment, or using lowercase bold or underline letters. Lowercase are called small letters sometimes. Alright, so to represent a vector on paper, you simply attach letters at the end of the directed line segment. So you draw a line with an arrow attached to it, directed. There's an arrow there to show direction. Alright, so you simply label them with letters, capital letters, at the end of the line. For example, you can say AB, alright, vector AB. Or if you don't want to use capital letters, you can use small letters. You just label them right there on the line. Alright. So that's representation. For example, this vector here, this is a vector, alright? It has the direction. The length of the line shows how big the quantity is, while the arrow is showing us the direction in which it is projected. So this is called vector AB, right? That's how you represent it on paper. It's vector AB using capital letters. So A here and then B. A vector is named using letters at the end of the directed line segment, or you can use lower letters such as small letters. So this vector is named vector AB. So the line there on top of the letters AB with an arrow at the end simply means or indicates that AB is a vector. Alright, it's a vector. So vector AB written like this. Or we can use a letter such as U, which is a small letter there. Just label this one, label the line, okay, as U. So this is vector U. Mind you, when you are typing this, it has to be bold letter, bold. So you change the font depth or density to bold. Or you can use, if you are drawing this using pen or pencil, then you have to underline the letter U to show that it's not just a letter, ordinary letter, but it represents a vector. It represents a vector. So you have to underline it. So these are ways of representing vector quantities. Vector quantities. So you can use you can label the line AB, X, Y, whatever, capital letters, alright, X, Y, alright, Y, Z, or CD, and so on. And you indicate that it's a vector. If you capitalize the letters AB, make sure you indicate on top there that it's vector AB. Or you can simply use a bold type. Bold is that one which is deep black letter, which you get from if you are typing this on a computer. Or if you use a light density of letter, which is not bold, then you have to underline it here. That's how you represent vector quantity. All right. A vector may also be represented in what we call a component form. Remember that a vector, a single vector, can be resolved into vertical and horizontal components. Remember that we call that resolving vectors in physics. So a vector can be represented using its components. For example, if we have a vector AB, or represented by D, we can write it as in component form. This is called component form. All right, you'll be asked to write a given vector in terms of its components. So a vector has x and y components. This is horizontal component. This one is the vertical component of it. When it drawn only on a Cartesian plane, on a xy plane, which we call Cartesian plane. All right. For example, this, so we have vector CD and vector EF. All right. So we can represent these vectors using their x and y components. The components are simply the parts of a vector, single vectors, which were added up to produce the given vector. So example here, two vectors were added to get this. So what are the vectors? What are the vectors which were added? So we have x component along the x axis and the y component along the y-axis. So those were the vectors which are added to produce this. So what are these vectors? We call them x and y components. All right. So if this is our vector w, this is our vector z, then this vector, in terms of its components, is a 4 by 2 vector in terms of xy. Where are these numbers obtained from? All you have to do is from C there, count 4 centimeters, whatever this is. So you count 1, 2, 3, and 4. This 4 here. So this is the x component. X component, while the y component is simply 1 and 2. So if you look at this, this is x, there are 4 centimeters or 4 squares. 1, 2, 3, 4. All right. While upwards, we have 1, 2. So this is a 4 by 2 vector. A 4 by 2 vector. While this one here, if you look at this, all right, this one is in the negative direction, all right, in the negative direction, so you have to consider that also. FE, its x component measured from here, it is going to be 1, 2, but this is in the negative direction, so it will be negative. Okay, it's okay. This is still in the opposite direction for x, so you count 1, 2, all right. But for y component, you are dropping down. You are not going up. We're dropping down here, so it will be minus 1. So this is a 2 by minus 1 vector, represented in terms of its components. The magnitude of a vector, or the size of the vector, is represented by simply taking the absolute value of that vector, written like this. These two lines here are used to mean magnitude or size of a given vector. So you can write it like PQ, then you border it with these vertical lines. Or if it's represented by a single letter, you also border it with these two vertical lines. So in order to calculate the magnitude of a vector, all you have to do is to apply Pythagoras' theorem. What is Pythagoras' theorem again? From your Form 2 mathematics. Pythagoras' theorem is simply a statement which applies to right angle triangle. It says that the square of the hypotenuse of a triangle is equal to the square, the sum of the squares of the other two sides. So you take the two sides, square each one of them, and add. The result is going to give you the magnitude of the vector. So consider a vector PQ. This is our given vector. We want to find the magnitude of this vector, the size. How big is it? So to do that, you shall need the y, the x component, and the y components of it. For example, here the x component of this vector is 4. So you have 1, 2, 3, 4. Well, this is the x component, all right? Its vertical component is going to be 1, 2, 3. So you square these two sides and add the results. It will give you the magnitude of PQ. So the magnitude of PQ is equal to the square root, right? You need to take square root. You want to find it PQ, Yeah, so you shall need to use Pythagoras' theorem. You square this, add them up. Whatever value you find, you take square root of it, and then that will give you the magnitude. It's just a number, right? It's not a vector anymore. It's just a number. How big is it, right? How big is this vector? All right. So that's how you'd find the magnitude of a given vector. From the plane here, you see the x component is 4, while the y component is 3. Okay, so we are representing them by letters A and B, all right, generally, so that we have this equation, magnitude, written like this. Don't just write the PQ, no. The PQ, the vector PQ with vertical lines. And then you take square root of the 2. You square this, you square that, you square the A, you square the B, and then take the square root All right, so that's what we have. That's what we have, all right? In terms of magnitude, what is the magnitude of a vector? So you simply take the modulus. This is called modulus. I mean the absolute value of that vector. All right, that's great. For example, let's look at this example here. We are given the vector CD for us to calculate the magnitude of it. All right, so this is vector CD. It's shown here. It's a vector. It's not just a line. How do you know that? This one, the arrow on top, is very important. Or if you are using the lowercase letter there, you have to underline it. If you are not underlining it, you are typing on a computer, then make it bold. Great. Okay. So its magnitude is going to be calculated using this general formula here. So we have this side, which is A, and this side, which is B. Then you just substitute into this equation. So we shall have 4. Where is the 4 coming from? It's just count these squares here. We have 1, 2, 3, 4. And then you count 1, 2 upwards. Alright, so the magnitude therefore of this vector, this vector CD, is the result of the square root of the sums, the sum of these two. So therefore the magnitude is root of 20, which is the same as 2 root 5 in third form. Alright, but you can go ahead and use a calculator to find what this is. This is a third expression, third. Remember, rational, irrational numbers. Yeah, so root 20 is the same as 2 root 5. All right, so that's how we find the magnitude of a vector, how big the vector is. Remember that the magnitude of a vector is not a vector itself, it's just how big it is. It can be a force. How big is the force in newtons? Or how big is the velocity in meters per second? Or how big is the displacement in meters? All right. So that's how you calculate the magnitude of a vector. So given a vector such as this, to find its magnitude, all you have to do is write the general expression. Okay, the general expression. Here you can also put x squared or y plus y squared. It doesn't matter. It doesn't matter. It's just a general expression of it. So take the modulus of that, the absolute value of this, and then make necessary substitutions. So it will give you this one here. Remember that the number on top represents x, and the one below represents a y. So substitute x squared plus y squared there, and take the square root. Notice that we are using Pythagoras theorem, which says that the square of the hypotenuse side is equal to the sum of the squares of the other two sides. All right, let's look at another example of a vector whose magnitude is to be calculated. Right. So here, the value of x is -4. We are moving from here. We are going to the left. So it's minus. The minus there is depicting direction in which we are moving. So we have -4. And we have 3 moving from moving from here upwards to point Q. It's 1, 2, 3. All right, so therefore this vector is a -4 by 3 vector PQ. Don't forget to put an arrow there to show that it's a vector. Otherwise, if you don't, it will just appear to be a line, just a line. All right. So we bring in our general equation here. The general equation is simply this one. The magnitude of vector W, this is vector W, you can call it, is equal to the square root of the sums of the two sides of the triangle. If you complete a triangle here, right angled at some point there, you will get this formula here. So substituting, it will give us square root of -4 squared plus 3 squared. Just taking these values here. All right, so squaring -4 gives us 16. Remember that the minus number, when it's squared, it will give you a positive number. So -4 squared, it will give you 16. It's like I saying -4 times 4. -4 times -4 is 16. The minus gives 16. And then you have 3 squared, which is 9. All right, so you square this, you add them up and take square root. All right, so adding this gives us the what does it give us? To give us 25. 25. So square root of 25 is 5. All right, so the magnitude of this vector is 5. So easy to do. So very easy to do. All right. If you have questions relating to this, please don't hesitate to call me or send me a voice message or text to the number that I gave you earlier on. All right. Let us look at what we call eco-vectors. Under what conditions are two vectors equal to each other? Vectors are said to be equal only if they both have the same magnitude, the length, and the direction. Vectors are equal if and only if both have the same magnitude and the direction. Then such vectors are called eco-vectors. So those vectors are the same. But if the two vectors have the same magnitude while differing on the direction, then they are not equal. All right, so it's possible for vectors to have the same magnitude but different directions. Such vectors are not considered to be equal. Vectors are equal if and only if both of them have the same magnitude and direction. In other words, vectors are equal if they have equal components, x and y. All right, so you have two vectors. Both of them have equal components. If you take the use the Pythagoras theorem to find the magnitude, you find that they are the same. All right, by virtue of having equal components. So for vectors, if these two vectors, we have vector A by B, vector V, C, D, if the values of U and V are the same, then it also follows that the components A and C are the same, and B and D are also the same. So such vectors are considered to be equal under such conditions. If V and U, vector U and vector V are equal in magnitude and direction, then it follows that the components are also the same. That's what we are saying here. However, if the components are different, let's say the x components are different, meaning that they are not equal, then these two vectors U and V are not equal to each other. All right, so let's look at vectors which are equal to each other from this given example. So, which of these vectors may be considered to be equal? So first of all, remember that two vectors are equal if they have the same components. That's the xy components, and they are in the same direction. All right. So if you look at vector A, its components, x component is 3, while its y component is 1. Look at B. Its x component is -2, right? Because counting this from here to there, it's -2, while its y component is 3. If you look at C, it has x component of 3 and y component of 2. While D does not have y component, it only has x component. So we have 3 here. 1, 2, 3. E, the x component is 2, the y component is 3. While F, the x component it has is 2, and its y component is 3. G has x component of 1, and x component is 3, while its y component is 1. H does not have y component, it has only. So look for those vectors which are equal based on the components. All right, which ones do you think they are equal to each other? Which vectors are equal? All right, so here you can see that vectors E and G are equal to each other. Why are we saying they are equal? It's because consider vector A. Its x component is 3. Count 1, 1, 2, 3. This one 2, 1, 2, 3. While y-axis, y component is 1, and this one 2 is 1. Therefore, A is equal to G. All right. Do you think there are any other pairs of vectors that are equal? Okay, you can check that. Thing to do, just to add the 2 like that. So the sum of these two vectors, A and B, is literally adding the corresponding components. So it will be, here it will be 2 plus the x component of the resultant will be 2 plus 6, which is 8. And you can actually see here, it's 1 from here. It's 1, 2, 3, 4, 5, 6, 7, 8. All right. Similarly, adding 4 to minus 3 is 1. It's the same as 4 minus 1. I mean 4 minus 3. So it will give you this component there. So the resultant of the two vectors is h by 1. All right, that's good. Another example of vector addition. So we are given vectors A, B, B, C. The resultant is the one that completes a triangle here. This is called the triangle rule, which states that if two vectors are taken in the same order, both in magnitude and direction, such that they form two sides of a triangle, the resultant of the two vectors is just the third side, which completes a triangle in the opposite order. All right. So if we let AB, vector AB, to be 3 by 4, 3 taken from where? This is 1, 2, 3, 4 is from here 1, 2, 3, 4. All right. Remember, we are representing vectors using their components, x and y components. Okay, such that BC is another vector of whose components are 2 by minus 5. So this one is dropping down to minus 5 here. This is 1, 2, 3, 4, 5. Minus 5, but it's dropping, it's going down below y. All right, that's why there's minus sign there. And its x component is 1, 2. Yeah, so to find the sum of the two, you can see here clearly that this vector is going to have a magnitude, the resultant of what? the sum of A and B. AB and BC is AC here. Just complete a triangle. Taken in a nose to tail direction. All right. So the sum of the two vectors AB plus BC is equal to another vector AC. So all you have to do is add the corresponding components to find AC. To find AC. All right. To find AC, just add AB. But mind you, they are vectors. Don't just add them ordinarily like you add numbers, ordinary numbers. No. Treat them in a vectorial way. All right. So in this case, if you substitute, so AB is the 3 by 4, while BC is the 2 by minus 5. So we get the resultant of these two vectors, the sum of AB and BC, which is AC, as 5 by minus 1. Here, the minus 1 is down here. You go down, you're dropping. It's like moving from here to there. You're dropping by one step down. This is minus 1. So the 5 can be also seen. It's 1, 2, 3, 4, 5. Which is this one here. All right. So far, I believe, so good. Ensure that you, given situations where you have to add vectors, you should be able to do that without problems, without challenges at all. It's so easy to handle vectors. So that AC is now going to be 5 by minus 1. So AC is what you get when you add the vector AB and the BC. If you check the components of this vector, this is 5. 5 where from? Let's see, 1, 2, 3, 4, 5. To the left, to the right of X. So 5 steps. Okay. All right. So in general, when it comes to adding vectors, if we are given vectors U and V, remember these are vectors, you underline, all right? If you are given two vectors U and V, in general, we are saying that if U equals to AB and V equals to CD, then the sum of these two vectors is simply found by adding the corresponding components. So in this case, the sum of U and V is going to be U plus V, which is AB plus CD. Just add the components, all right? So you have A plus C and for the X component, and B plus D for the Y component. All right. So that's what we have. That's what we have there. Okay. So that's in general what you do to get the sum of two vectors given in component format. Let's look at another important terminology which is called zero vectors. Zero vector. By definition, a zero vector is simply one which is obtained when the sum of the two vectors is equal to 0. So we are saying, given two vectors, any two vectors, if the sum of those vectors gives us 0, then that resultant vector is equal to, or is called a zero vector. So this is done by simply reversing the signs of the vectors. So here, if we are given AB as 1 by 2, then reversing AB is going to give us BA. All right. So you see this is negative 1, and negative 2 downwards. Similarly here, this is positive 1, this is positive 2. So AB and BA, following the arrows there, are two opposite vectors whose sum will give you 0. So the resultant vector is the one which we call a zero vector. A zero vector has a value of 0. So when you add vector BAB by its reverse, you simply have to negate this one to get BA. So when you add the two, it will give you 0, 0 situation there. So what we are saying is, when one vector is reversed so that the two are added up, the result is going to be 0. So the vector 0 by 0 vector is called a zero vector and is written as 0 with the underscore there. You score it down there. Just underline to show that the vector is a 0, 1. Obtained when one vector is reversed in terms of direction. So you add the vector and its negative value, which is found by opposing it, reversing it. So the result is going to be a 0 vector. We come to another vector which is called a negative vector. A negative vector, as I alluded to the previous example of 0 vector, is simply the reverse of a given vector. For example, if we look at vector BA, is simply the negative of AB, just reverse. So AB, the opposite is BA. So BA in this case is called negative vector. So for any vector U, the result of adding a vector to its negative is equal to 0. Here you have a positive sign followed by minus sign. The result is 0 situation. This is 0. All right. So the sum of a vector and its negative produces 0. right. So that if vector u is a, b, then vector minus, you negate this one here, it will change the signs of the components in the brackets there. It will give you 5 by 0. So that's 6 minus 1, and the 3 minus 3 to give you this vector here. That's how you subtract the vectors. So vectors being subtracted face each other in a head-to-head direction. All right. So notice the arrows here once again of the two vectors being subtracted. They are nose to nose, eh? All right. This one nose, this one nose, or head to head. So the sum, the product, rather the difference between A and B is another vector which completes a triangle. So what will be the value of the difference? So we can let A be 6 by 5. This is 6 by 5. How? This is 1, 2, 3, 4, 5, 6. To the left, to the right. Then 1, 2, 3, 4, 5. Upwards. That's this one here. While B is going to be 2 by 4. So this is 2. So we have 1, 2. So that the y component is going to be 4. So we have 1, 2, 3, 4. So we are subtracting the two vectors here, a minus b. So what will be a minus b? All you have to do is to subtract the corresponding components there, and what you find is going to be the difference between the two. Notice here that when you are adding vectors, you are subtracting vectors. Subtraction is essentially the same as addition. Here you see a minus b is just the same as a plus the minus of b, because a positive sign followed by a minus sign always gives a negative sign there. So the difference between the two is going to be going to be 4 by 1. So that's how you subtract vectors. All right. So the difference is 4 by 1. So in general, when these vectors are being subtracted, in general, we say for vectors u and v, for vectors u and v, all right, for vectors u and v, given that vector u is a by b and vector v is c and d, u is a by b, v is c by d, then the difference of these two vectors is simply found by subtracting the corresponding components. So by corresponding components, I mean the x components subtract each other and the y component also do the same. Don't transverse this. Don't say a minus d. No, you go wrong. You will not get the answer. So in this case, v minus u is the same as vector AB minus vector CD, so that we get this one here. It's so simple. So if you know the components given a vector in component format, two vectors in component format, the difference between them is just subtract. Yeah. Sometimes there is need to multiply a vector by a scalar quantity. Multiplication of vector by scalar quantity. A scalar is just a number, remember that? It's just a number, like, having magnitude only. So you multiply any vector by, think of a number, maybe 1, 2, 3, minus 1, minus 2, minus, whatever number, right? It can be a fraction, whole number, So you can multiply a vector by a number. For example, if a vector v is given by x by y, then kv, where k is a number or scalar, you just distribute the k into these brackets here. So here you shall have kx, and here you shall have ky. You're just multiplying the vector by a constant number, which is a number here, scalar. Like it can be 2, 3, 4, 5, or minus 1. It can be a fraction such as 1 over 2, or half, quarter, 3/4, and so on. So you multiply the vector, given vector, by a number. This number is called scalar. So the vector kv is parallel to vector v, but different sizes. In other words, they are in the same direction. They only differ in size. For example, kv is many times, is a number of times of v. Say, for example, if this is a 2, that means kv is going to be twice v. That's what we mean here. But they are in the same direction, regardless of the sizes. So this one can either, the k, the multiplication by scalar, can either amplify or multiply, increase in size the original vector, or diminish it or reduce in size. All right. So therefore, if u is kv, then u is parallel to v. If vector u is given by a vector v multiplied by a certain amount, then vectors u and v are in the same direction. They are parallel to each other, but not necessarily equal in size. All right. So in a reverse way, if u is parallel to v, then u is equal to kv, whatever value of k is. All right. Just multiplying a vector, given vector by a number, it will give you a different vector which is parallel to the original vector. So if vector u is equal to kv, then it means that u and the v are in the same direction, although they are different in size. So let's look at these two vectors. We have vector a and b. We are asked to write down a vector parallel to a. Right? Parallel to a. And also write down a vector parallel to b. So all we do is multiply a and b by a number. Multiply a separately, okay? multiply a by a certain number, let's say twice, we multiply by 2, it means it will be longer. It will produce a longer vector, but in the same direction as the original one. Similarly here, if we multiply this vector by a number, that vector, the new vector, can be either bigger or smaller, but in the same direction, parallel. Alright. Sometimes we can show whether the given vectors are parallel to each other. Parallel vectors are in the same direction, despite having different sizes. So here we have two vectors, W, then, and another one is Z. We can show that these vectors are parallel to each other. How do we show that the two vectors are parallel? So remember that if a vector Z is equal to a vector W multiplied by a certain value, then Z and W are parallel. Okay, that's what we said earlier on. So here we need to find what K is by factorizing that. Okay, let's call it factorizing. All right, find common multiple, common number that can go both into 18 and 30 and 27. So such a number is 3, because 3 times 6 gives us 18. 3 times 9 is 27. Right, so this is vector Z. When you factorize it, you take out 3, just take out 3. The goal is to produce a vector which is similar to the given vector W. So here we have 6 by 9, here also 6 by 9. Okay, which means to obtain Z, the vector W was just multiplied by 3. So this 3 here is a scalar. It's a scalar which multiplies the vector W to obtain vector Z. So when this happens, therefore, we say that vector W and the Z are parallel to each other. They are in the same direction, but different sizes. So in this case, you see that Z is simply 3 times W. Okay, 3 times W. So this is an indication that the two vectors are parallel to each other. The alternative approach to this is we are saying that if W is equal to KZ, if W is equal to KZ, then W is parallel to Z. All right, so in this case, what you do is to factorize this again, or rather to multiply this by 1/3. You can see W here, this vector here, is found by taking 1/3 of Z. This 3 goes into 18, it will give us 6, and 3 into 27 gives us 9. All right, so that W now is 1/3 of Z. The fact that to obtain W, we have to multiply Z by a certain number, it makes the two vectors parallel to each other. All right. Let's look at another type of vectors, which is called unit vectors. The word unit means 1, eh? All right, unit. When you see the word unit, means 1. So for any vector V, there exists a parallel vector U of magnitude 1. For any vector V, there exists a parallel vector of magnitude 1. So this vector whose magnitude is 1 is called unit vector. Unit means 1. Suppose we are given here the two vectors. We are asked to find the components of the unit vector u parallel to vector b. If v is equal to 3 by 4. So all you have to do is find the magnitude of v. Remember how to find the magnitude? You simply square both and take square root. Right? Which gives us 5. So it has a magnitude of 5. Alright? So the unit vector is the u, given by u equals to 1/5 of vector v. Alright? So such a vector, if you distribute this, shall give you here 3 divided by 5, down here 4 divided by 5. So this is called a unit vector, or a vector whose magnitude is going to give you 1. A different type of vector is called position vectors. If you look at this here, the Cartesian plane, you have these two vectors that are coming from the origin here. This is called the origin in mathematics. So A is the point given by 3, 4. 3 is for x1, 2, 3, and this is 4. That point A, the coordinates of that point. And B is has the coordinates 5 by 2. 5 you count from the origin. So you have 1, 2, 3, 4, 5. And this side 2. Alright, so let's look at the components of these vectors, OA and the OB. So OA you see is 3 by 4. 1, 2, 3. 1, 2, 3, 4. OB is has a component, the components of 5 by 2. That's 1, 2, 3, 4, 5. 1, 2. All right. So to find vector AB, we simply have to add these vectors, the sum, completing a triangle there. All right. So to find AB, all we do is simply subtract OB minus OA. The difference between these shall give us AB. All right. AB. It's like we are looking at two vectors, OA and the AB, to give us this vector OB. Vector OB is just the sum of vectors OA and AB. So if the sum is OB and the one of the vectors is given as OA, what will be the value of AB? Just subtract. So you just subtract to find AB. Yeah? Just subtract OB minus OA. It will give you 2 by 2 vector. So AB, vector AB given OA, these are called position vectors because they are originating from the origin here. They're coming from the origin. So these two vectors are called OA. O refers to origin. Eh? All right. So the difference between the two to give you the resultant of 2 by minus 2. Alright. So OA, vector OA is called the position vector of the point A relative to the origin O, written as this. Okay, so we are saying a vector which originates from the origin, okay, which comes from the origin, is called positional or position vector. So that OB is another vector also from the origin, written as B. Alright, so these two vectors are position vectors. Why? They're coming from the origin. So the sum of these two vectors A and B is simply AB, this one. If you go back to addition of vectors, the two vectors OA and AB are in a nose to head, in a nose to tail direction. If two vectors represent two sides of a triangle taken in the same order and the direction, then the resultant of the two vectors is a side which completes the triangle in the opposite direction. Right. So here A plus OA plus AB is equal to OB. So that means to find AB, all we have to do is subtract OB minus OA. It will give us AB here. So vector AB is equal to the sum of the two vectors, which you have to reverse. You reverse this one, transact it, reverse it, so that the value is going to be the same as B minus A. So that's positional vectors. Please, if you are unsure about what we are discussing now, don't hesitate to come back to me and in form of question. Yeah, it's 2. So you subtract Q. Q is this one. Q is the vector which is mentioned last, and P is the one that is mentioned first. So in this case, subtract the 2, it will give you. Remember that QP is not the same as PQ. They're different. If this was QP, then you'd also have to reverse this one here to give you that value. So we can show graphically, if we have a problem in graphical form, we have two vectors, OP and the OQ. We want to find QP, this one here. So all you do is just, subtract the 2. So this one is going to be Q minus P. To give us the resultant there. So thank you very much. It has been a long lesson, but worth following on. We've come to the end of lesson 1 of vectors. All right. So in case of doubts or questions, don't hesitate to contact me on the number shown here. All right, and send your question in form of voice or whatever format you can send. That's okay. For now, we say bye-bye. Again, we meet next time in our second lesson.